So this video is also on dimensional analysis. I decided to put in a second one just to show you what happens when you have a coefficient or a fraction or some multiplier on one of your quantities. They really make no difference at all. Okay, so in this case we're asked to evaluate the quantity x here and see what kind of a unit is on our quantity x. So again, all the other ones are known quantities. S is displacement, u is initial velocity, so it's velocity in meters per second, and t is time in seconds. So again, we do the same thing. I don't need to worry about this one at all because these ones are all known. But I do need to worry about this one because the x is unknown. But I'll take it in two halves, and you know what we'll do? We will double check the units on this one first, okay? So I'm just going to say that the units of this, the units of displacement must be equal to the units of velocity. So this is u, the unit here, times the unit of time. And I know that the unit of displacement is meters. And that must be equal to meters per second times some time unit. And of course, we know they are. So the seconds cancel here, and meters is equal to meters. So that's fine. Double check that one. Now we'll do the second one, where the coefficient comes up. I've got a half x, whatever x is, times t squared. So the half really makes no difference in this, because again we're looking at the unit here, not number. Okay, and that's what these square brackets are kind of indicate, is that the units of these quantities must be equal. So again, I know I've got meters here, and it must be equal to, again, the half makes no difference, so I can just forget about it completely. The units of x, so I'm going to leave that in a square bracket, times the time unit squared. Well, I know that time is measured in seconds, so that's got to be seconds squared. Sorry, I will change that from a square bracket to kind of a curvy one. It's a 2, not a 1. Kind of looks like it's 2, 1 there. Again, I'm just going to work a little bit of algebra here. Divide both sides by seconds squared, and that gives me a unit of x equal to meters per second squared. And of course, you probably knew that to begin with anyway, because you probably recognize this equation as being s equal to ut plus a half at squared, and that is the unit of acceleration. And so is this. So it just turns out that in this example, the x was a unit of acceleration. Okay? But I suppose the key point from this was that if you have a coefficient or some multiplier on the front of a number or front of a quantity, it makes no difference to the units. Okay? It makes no difference whatsoever, so you can just forget about that completely, and you can deal with it in the same way as